Welcome to Ganitika.com. This is a website for mathematics lovers, learners and leaders. This is the last video in the series of prior knowledge for IB Maths AA and AI, both HL and SL students. And in this video, we'll be discussing the topics on statistics, probability and functions. First of all, let's see the topics on statistics. The first thing that you need to know on statistics is what is data, how to collect data, and how to represent data in these four forms: bar chart, pie chart, pictogram and line graph. What is collecting data? Data collection is the process of gathering, measuring and analyzing data from various sources. For data collections, there are two major methods. One is called a primary method, the other one is secondary method. Primary method is where you collect the data by yourself, which is called first-hand data. Some of the examples of primary data collection is interview, survey and measuring by yourself. You can measure the things by yourself. You can use personal interviews or survey forms, etc. These are some examples of primary data collection. And for secondary data collection, these are the data that are formed from other resources such as websites, government publications, journals, etc. So when you get data from other resources, they are called secondary data. When you collect the data by yourself, it is called a primary data. So you should be knowing the difference between primary and secondary methods of data collection. Next, we will proceed to representing data in these four forms: bar chart, pie chart, pictogram and line graph. For this, I will be using an example. A survey was conducted for 60 customers by a bakery shop on the demand of different flavors of cakes in the shop. You can notice that this is a primary data collection because it's a survey conducted on 60 customers by the bakery shop itself, and they have noted the flavors that the customers like on the cakes that they produce. So the result is given in the table below. Pistachio, there are 11 customers who like pistachio cakes. There are 23 customers who like chocolate cakes, 5 like banana, 12 for strawberry, and there are 9 customers out of 60 who like vanilla cakes. Now we need to represent this in bar chart. So let's first start with bar chart to represent this particular data set. For bar chart, you need a graph sheet like this. On the graph sheet, the y-axis will be the numbers that you collect from the data. So in this case, the minimum number is 9, the maximum is 23. Accordingly, you will make the scale here. I have made it as 1 centimeter equal to 2 units. So my y-axis contains 2, 4, 6, 8, 10, etc. all the way to 26 to accommodate 9 to 23 in the set. Correct? On the x-axis, what I will do is I'll write the flavors: pistachio, chocolate, banana, strawberry, vanilla between the two dark lines of the x-axis like this, so that I can make bars for each of these flavors. For example, for pistachio, I'll make a bar all the way up to 11 because there are 11 customers for pistachio. I'll take the bar all the way to 11, and then for chocolate, it goes all the way to 23. For banana, it's up to 5, strawberry to 12 and vanilla to 9, and these are the bar representation of the data given there. You can easily see that the pictorial representation is much better than the tabular representation, right? You can immediately say that the banana is the least favorable cake and chocolate is the most favorable cake, right? Let's go further and see how to represent the same data in pie chart. For pie chart, you need to find something called angle here because pie chart is inside a circle. It goes with the angle inside the circle. Therefore, in order to find the angle for each of the flavors, you need to find the number of customers divided by the total number of customers. Multiply this ratio by 360 degrees. So for example, for pistachio, number of customers is 11, total customers is 60. So 11 over 60 times 360 degrees. So the angle for this is going to be 66 degrees if you calculate that. So in order to represent this 66 degrees on a circle, make a circle of any radius. Start with any one of the radius. Usually we start with the horizontal radius on the right side like x-axis. It's easy for us to start with. So we'll start with this radius and we'll measure 66 degrees from this radius and we'll complete the sector. And then we will shade the sector and call this as pistachio. So this sector is for pistachio, which represents 66 degrees of 360 degrees in the circle, right? Now go for chocolate. Chocolate is 23. 23 over 60 times 360 will give you 138. So the degree for chocolate is 138. Therefore, this is a sector containing degree of 138. You have to be careful that this angle should be made from the end of the previous sector, not from the first line. At the end of the pistachio, you should start measuring 138 degrees and make the new sector here. Color this sector, shade this sector and call this as chocolate. So for chocolate, this sector represents 138 degrees, which is equivalent to 23 people out of 60. Now for banana, do the same thing. 30 degrees is the degree representing for banana. Make the sector from the end of the chocolate sector, shade it and write banana in this. Can you complete this picture by pausing the video here? And the answer for strawberry is 72 degrees. So you measure 72 degrees from the end of banana sector, complete the sector and shade the sector, call this as strawberry sector. Okay. Now coming to the last one, vanilla, the degree here is 54 and you need to check whether this is actually 54 or not, because you should end up with the beginning in order to make this all total up to 360 degrees. If it doesn't end up to the beginning of the pistachio, then you have made some mistake in the angles that you have calculated. Therefore, be sure that this measures the last degree properly. Here it is 54 degrees and this represents the vanilla position, right? Next, we will move on to pictogram representation of the same data. For pictogram, we'll use the same table as before, but we'll use, instead of numbers, we'll use pictures. In this case, I'm going to use this picture as key for 2 customers. So one piece of cake for 2 customers, which means half the piece of cake will be for 1 customer. This key is very important before you do the pictogram for any data, because without this key, nobody can understand what you have done. For example, if I write pistachio as 1, 2, 3, 4, 5 and a half, if I represent pictogram for pistachio as 5.5 piece of cakes, you should know that each cake represents 2 customers and half the cake represents 1 customer, right? Only then it will all represent together to 11 customers. So without the key, we cannot find out how many customers are there for pistachio. For example, for chocolate, in this key, 2 customers, 4 customers, 6 customers, 8, 10, 12, 14, 16, 18, 20, 22. So we have got 22 customers so far, but we need one more customer to represent 23. So I'll use the half cake here to represent 23 in total for chocolate. You can continue and complete this table. If you want to draw a picture on your notebook, you can choose any picture you want, but be careful to write the corresponding key for the picture. So the next representation for banana would be 2, 4 and 5. For 12, 2, 4, 6, 8, 10, 12. So there are 12 for strawberry. There is no half cake here because it's an even number. For vanilla, it's 9. So 2, 4, 6, 8 and then you have half piece here for representing 9. So this is the pictogram representation of the given data. Again, remember the key is important. Next, we'll go for line graph. For that, we'll use the same graph that we did for bar graph, and we will only move the x-axis representation to the line not between the lines like this. So your pistachio, chocolate, banana, strawberry, vanilla, the categories will be written over the dark lines of the x-axis, and we'll remove the bars. For each of the categories, we will represent the value as a dot against the category. For example, pistachio has 11 members. Therefore, the dot will be on pistachio against 11. And chocolate for 23. Banana for 5. Strawberry 12. And vanilla 9. And we'll just connect these points together one after the other in this sequence. And then we have the line graph that represents the data given here. So we just learned different types of representing the same data. So each representation will be used for different purposes. You need to know these 4 types of representation, and you will be dealing more with each of them in your DP classes. Next, we will talk about statistics on discrete data. They are finding mean, median, mode, and finding range. Finding range is very simple, and I'm not going to do this in this video because range is nothing but the maximum value in the data minus the minimum value in the data. So it's going to be very simple. But we'll see how to find mean, median, and mode for discrete data. First of all, we'll see how to find the mean. But what is a discrete data? It's a data that can be counted. For example, number of students in a class, where you can actually count 1, 2, 3, 4, 5, etc. Shoe sizes, number of customers in a shop. All these are examples of discrete data where you can actually count the data, right? Let's try to find the mean of the following data that gives the number of books read in June by the members of a book club. 2, 5, 3, 2, etc. This means one member of the book club has read 2 books in the month of June. Another member has read 5 books in the month of June. Another member has read 3 books in the month of June, etc. So there are so many members who have read so many books in the month of June. And for this, we need to find the mean. So the formula for finding the mean is sum of all the values divided by total number of values. So in this case, we need to find the sum of all the values that is given in the data. And there are 20 data here because there are 20 members in the book club. And therefore, the total number of values in the data is 20. And you have to sum up all the values here on the numerator. Simplify this. you will get 3.45 as the mean for this data. Now let's proceed to find median and mode for the same data. For median, you need to find the middle value of the data when written in ascending order. So we'll take the data first and then we'll write this in ascending order. Pause the video here and write this data in ascending order. I'm going to do this quite fast here. Maybe you will not be able to follow this, but if you do it on your notebook, it will be simple for you to understand. So all the ones together, then comes the 2s and then 3s and then 4s, 5s and 6s together. And this is in the ascending order. After writing this in ascending order, number them because there are going to be 20 numbers here. We know that there are 20 set of values here. So number them because we need to find the middle value, right? So total is 20. In order to find the middle term, we need to use the formula n plus 1 over 2 where n is 20 here. Therefore, this is 21 over 2 which is 10.5. So the middle term is the 10.5th term, right? But we don't have 10.5th term here. So it is between 10 and 11. So 10.5 stays between 10 and 11, which means you need to find the average of 3 and 4 here. The number in the 10th place is 3. The number in the 7th place is 4. And you need to find the average of these two numbers 3 and 4, which gives you the median as 3.5. And then going for the mode is the most frequently occurring value in the data. You can see that 4 occurs the maximum number of times, right? The value 4 occurs 5 times, whereas all the other values are occurring less than 5 times. Therefore, the mode for this data is 4. You can notice here that mean is the most accurate measurement of the data, whereas mode is the least accurate measurement of the data, because mode just gives you which number occurs maximum number of times, whereas mean is the best measurement of the data set. So just make a note of this. It might be helpful in your DP classes. Next, let's go to see what are the topics under probability. In probability, you are supposed to learn only probability of very simple events. Before you actually go to find the probability of simple events, let's see what is the vocabulary that you need to know under probability of events, right? So for that, you need to know the words experiment, sample space, event and outcomes. What is an experiment? An example of an experiment is a coin is tossed. And the sample space for this experiment is all the outcomes that you get after tossing a coin, which is head and tail. So if you write head and tail in a set, then it is the sample space for the given experiment. So sample space for the given experiments is the set of all outcomes of the experiment. There are many events possible from an experiment. Event is part of an experiment. So from the experiment, if you want to see what is the probability of getting a tail, then the event will be getting a tail. The outcomes of getting a tail is the set tail. So you'll understand this better with the next example where we roll a die. The sample space from rolling a die is the set of numbers 1, 2, 3, 4, 5 and 6, because when you roll a die, these are the 6 numbers that you will get on the top of the die, right? And I can have many options for events here. Getting an even number is one of the many events that I can choose from rolling a die. For example, I can have another event which is getting an odd number, right? I can also have another event which says getting numbers less than 4. This is another event. So there are many possible events under rolling a die, but I'm choosing one event called getting an even number. For that, the outcomes are 2 and 4 and 6. If I put them in the set, then it is the set of outcomes. So these are the 4 important words that you need to know for finding probability of simple events. The formula for finding probability of any event is number of outcomes of that event divided by the number of elements in the sample space. So let's take an example. What is the probability of getting a tail in the first case when you toss a coin? The number of outcomes in the sample space is 2. Number of outcomes in the event is only 1, which is tail. Therefore, 1 over 2 is the probability of getting a tail when you toss a coin. Whereas when you roll a die, what is the probability of getting an even number? This will be 3 over 6 because there are 3 outcomes for the event and there are 6 outcomes in the sample space. 3 over 6 giving you half as the probability of getting an even number when you roll a die. You need to note 2 important points here. Probability of an event is equal to 0 means the event is impossible or it has 0% probability of occurrence. P of A means probability of an event A. Usually events are given in capital letters. So if it is equal to 0, the value of the probability is equal to 0, then the event is impossible event. Whereas if the probability of the event is equal to 1, then it is called a sure event, and which means it has 100% possibility of occurrence. So probability of any event can be between 0% and 100%. Therefore, P of A is always between 0 and 1, both inclusive. Let's continue with an example. A pair of dice is rolled. Find the probability of getting a sum of 5 and getting the same number on both the dice, right? On the top of both the dice, you have to get the same number. The first A question is getting a sum of 5, which when you add the numbers on the top of the dice, you should have a sum of 5. This is the meaning of the first question. And then the second question means you on the top of the dice that you have rolled, the top numbers should be same. For this, we will use a diagram called lattice diagram. We'll make x and y axis like this. And on the x axis, we'll put the outcomes of the first die, and the outcomes of the second die will be put on the y axis, and we'll make a grid like this. So nodes of the grids will be the outcomes. So total outcomes, we have 36, which is also the sample space. So there are 36 number of outcomes for rolling 2 dice, right? In question number A, you need to find the combinations which gives you the sum of 5, right? So what are the numbers that will give you the sum of 5? 1, 4, 2 and 3, 3 in the first die and 2 in the second die, 4 in the first die and 1 in the second die. These are the 4 combinations that you will use to get a sum of 5, right? So there are 4 outcomes for this event. Therefore, probability of getting a sum of 5 is 4 out of 36, which is also simplified to 1 over 9. This is the probability of getting sum of 5 when you roll 2 dice. Now pause the video here. Try to find the answer for question B. Question B says getting the same number in both, which means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. On the lattice diagram, you can see that these are the values that you will be marking on the lattice diagram. Also, there are 6 outcomes. Therefore, the probability will be equal to 6 over 36, which is simplified to 1 over 6. Proceeding further, let's find probabilities using Venn diagram. What is a Venn diagram? It is a representation of 2 sets like this. This is called the universal set, and this is set A and this is set B. You need to understand the shaded area here is neither A nor B, and shaded area here is both A and B. These are the important things that you need to understand now. And representing neither A nor B will be A union B complement. Both A and B will be A intersection B in mathematical form. So these are the things that you need to know. And when you see the part where it is not shade, this part is only A. A minus A intersection B will be only A. And this part will be only B, which is B minus A intersection B. You take away the A intersection B from B, you will get only B. So these are the information that you need to understand first. And next thing is how to find the probability of certain things. How do you find probability of only A, which is A minus A intersection B. Therefore, it is P of A minus P of A intersection B. Next is how will you find P of A union B complement? The whole set, universal set minus A union B. Therefore, the probability of universal set is 1. 1 minus probability of A union B will be probability of A union B complement. These are the things again you need to note before we proceed further with an example. So let's go to the example now. Copy this example in your notebook, pause the video and try to do this using your Venn diagram knowledge. In a class of 25 students, 10 take biology, 20 students take physics. 3 take neither physics nor biology. This is the most important part of the question. Find the probability that a student selected at random takes, number 1, biology only, number 2, both biology and physics. So you need to find the probability of biology only, probability of biology and physics, which is B intersection P. So let's make the Venn diagram first for this information. Universal set is the total number of students 25. B is biology, P is physics. Now the first thing that we know is that 3 of them do not take either physics or biology. So they will be coming out of both the sets B and P. So they will be put here. There are 3 members outside the circles, right? How is this going to help us? This is going to help us in finding the union of B and P. Because B union P complement is having 3 elements. Therefore, number of elements in B union P will be total number of elements, which is 25, minus this 3, which is 22. So 22 people take either biology or physics. Out of 3, we have taken the 3 people who have taken neither physics nor biology. So out of 25, if you take away these 3 people, the remaining 22 people are either in physics or in biology or in both. So we are going to separate them as only biology, only physics and both, right? Before going further, we need to understand that there is a formula which says now number of elements in the union is equal to number of elements of A plus number of elements of B minus number of elements in both A and B. So this is a formula that you would have known before. If not, this is given in the formula booklet for you. You can refer your formula booklet, and this is what you are going to apply now to find A intersection B now. So we have B union P, which is 22. and we have n of biology, which is 10. Number of elements of biology, we are given that it is 10, and number of elements in physics is 20. Now we need to find the intersection. Use the formula below. 10 for n of A, 20 for n of B, union is 22. Applying this in the formula, A intersection B, which is B intersection P, will be equal to 8, and this 8 will be positioned here in the intersection part. Once you write this, then you can easily find what is only B, which is 10 minus 8. There are a total of 10 people who have taken biology. Out of 10, 8 people have taken physics also. So only biology will be 10 minus 8. Only physics will be 20 minus 8. Out of 20 people who have taken physics, 8 of them have taken biology also. Therefore, only biology there will be 2 people. Only physics there will be 12 people. So 2, 12, 8 and 3 are the important numbers that you need to fill this Venn diagram with. Let's go further to find the probabilities. What is the probability of B only? How many members are there in only B? 2. What is the total number of members in the class? 25. So 2 over 25 will be the probability of only B. What is the next one? Biology and physics, which is B intersection P. How many elements are there in B intersection P? There are 8 elements. Total is 25. Therefore, the probability of B intersection P will be equal to 8 over 25. And this is how you use Venn diagram in finding probabilities of simple events. Let's go further to see what is tree diagram for probabilities. Let's take an example of tossing a coin. When you toss a coin, you have 2 outcomes, head and tail, right? So you have 2 branches in the tree, one for head and one for tail. You will write the head and tail on the end of the branches like this. And then you will find the probabilities of getting each of them. Probability of getting head is half. So you will put this half on the branch like this. The probability will be written on the branches like this. Similarly for tails, probability of the tail is half. You will write the probability on the branch for tail. So this is the total representation of tree diagram for tossing a coin. We'll do the tree diagram for rolling a die. Can you try it yourself before looking into the further explanation in the video? How many outcomes are there? First of all, you need to see how many outcomes are there. 1, 2, 3, 4, 5, 6. There are 6 outcomes. Therefore, you will have 6 branches for each of the outcomes. The outcomes will be written at the end of the branches. On the branches, you will write the probability of each outcome. What is the probability of getting 1 in rolling a die? There is only one option out of 6 options. Therefore, 1 out of 6. Therefore, you will write the probability over the branch like this here. Similarly, probability of getting 2 is also 1 over 6. So, you will write the 1 over 6 here. Probability of 3, probability of 4, probability of 5, everything is going to be the same. You will write the probabilities on the branches like this. So, the probabilities will be written on the branches, whereas the outcomes will be written at the end of the branches. This is what you need to understand now. And the number of branches will be the same as the number of outcomes. So, these are the things that you need to note at this moment. We will continue doing one example. Tossing a coin and rolling a die together. So, you are going to toss a coin as well as roll a die together. What is the probabilities of many events from here? So let's first draw the tree diagram for tossing a coin. This is the tree diagram we just saw for tossing a coin. Now for rolling a die, you know that you have 6 branches for rolling a die. So the 6 branches will be drawn from H as well as from T. So the total number of outcomes you have now is 12. So 6 for H and 6 for T. This is the complete tree diagram for this particular experiment, tossing a coin and rolling a die. Now let's say we want to find the probability of getting a head and an odd number from the die. Getting a head from the coin and an odd number from the die. Which means we are looking for head 1, head 3 and head 5. So 1, 3, 5 are odd numbers from the die, head from the coin, right? For that we need to see that these are the branches that we are looking for. H1, H3, H5. So we need to add these possibilities. So the probability for H is half and probability for getting 1 is 1/6 and for getting 3 is 1/6, or for getting 5 is 1/6. So H1 would be half times 1/6, H3 would be half times 1/6, H5 will be half times 1/6. H is half, 5 is 1/6. You will add all these probabilities because these are the 3 different options of getting a head and an odd number. And if you simplify this, you will get 1/4 as your probability for getting a head and an odd number from the given experiment tossing a coin and rolling a die. So you can also find getting a head and an even number in the same way, or getting a tail and an even number or odd number or number less than 4. You can have many events from this particular experiment. Accordingly, you should choose the branch, multiply the branch and add the options. This is what you need to take away from this particular section of this video. Next, we'll move on to the functions, which is the last topic in the prior knowledge. In functions, you are supposed to be knowing what are the mappings of elements of one set to another, and you should know how to illustrate these mappings using sets of ordered pairs, tables, diagrams, and graphs. And this is what I'm going to teach you just in few seconds. What is the mapping of elements of one set to another? We need to have two sets. Say for example, I have one set with A, B, C, D as its elements, and another set with 1, 2, 3 as its elements. So I need to map one set A, B, C, D to the set 1, 2, 3. This is called mapping, and all the mappings are also called relations. So there is a relation between A, B, C, D and 1, 2, 3. I can take a relation, for example, A is mapped to 1, A can be mapped to 3, B is mapped to 2, C is mapped to 1, and D mapped to 3. This is an example of many different relations that I can have between A, B, C, D and 1, 2, 3. A1, A3, B2, C1, D3 is the relation which is now represented as a set of ordered pairs. A1 is an ordered pair, A3 is an ordered pair, B2 is an ordered pair, C1 is an ordered pair, D3 is an ordered pair. So these are all ordered pairs which are given in set form, and the relation is represented in set of ordered pairs. Next, to represent this in table form, which is much easier, you can easily understand what this is. A1, A3, B2, C1, D3. This is the relation which maps A, B, C, D to 1, 2, 3 in different ways. Next, going to graph representation. I will come to diagram representation at the last. Next, we are going for graph representation. We will put the x-axis with the first set, and on the y-axis we will put the second set, and we will make the grid for this. And we will make the nodes A1. A goes to 1. So A is mapped to 1 will be represented by the dot at A1, then A3, then B2, then C1, then we will go to D and 3. So this is the way we represent the relation on the graph. This is much simpler. And how to represent that on diagram? You will go back to the sets A, B, C, D and 1, 2, 3 that I have shown here with the oval shapes. Now you just need to draw lines from A to 1, A to 3, B to 2, C goes to 1 and D goes to 3. So they are represented by connectors between A, B, C, D and 1, 2, 3. So this is the way how you represent the mapping or relation using diagrams. And in this case, something that you need to understand here is this set is called the domain of the relation, and this set is called the range of the relation, R. So domain is the first set where it starts from, range is the set where it ends at. So A to 1, A is in the domain, 1 is in the range. The next thing that you need to know is graphing linear and quadratic functions using technology, and you will be doing this much detailed way in DP classes. I'm going to show you only the technology that you will be using in DP classes. I'm not going to go in detail of how to use them, because it's going to be a wide range of technology that you can use. So I cannot restrict to the one particular technology, right? So the first thing that you will be using is something called graphing display calculators, and more is GeoGebra, Desmos, etc. And graphing display calculators are called GDCs, which is going to be used in your classes and your exams. But GeoGebra, Desmos, etc. are software which you can download for your computer, which can be used for your projects, so that you can copy paste the screen. You can screenshot from these software and put it in your projects. If you want, even in your internal assessments, you can use these software. You can freely download all these software, whichever is comfortable for you. You can download this in your computer and use it for your projects. But graphing display calculators are those which you will be using in your classes as well as in your examinations. And the models for GDCs will be given by your class teachers and the coordinators. So these are the things you have learned in this video: collecting data, representing the data in 4 different forms, mean, median, mode and range, probability of simple events, Venn diagram, tree diagram for probability, and functions, mapping, linear, quadratic graphs, right? I hope you enjoyed watching my videos under this playlist. Thanks for watching. Please do not forget to subscribe, like and share my videos with your friends and families. Thank you very much.